Hello, everyone. Welcome to my presentation of IP addressing. In the previous chapter, we have discussed the network medias. As we know, network media is located at the physical layer of the OSI reference model. And then we have discussed the Ethernet. As we know, Ethernet is located at the data link layer of the OSI reference model. And now we come to the IP protocols. The IP protocol is located at the network layer, the third layer of the OSI reference model. And as we know, the function of the network layer is to identify the source and the destination and choose the best route from source to the destination. Okay, and how to identify a source and the destination? We use address. So there's an IP address is the most basic concept of the network layer. Okay. Then the objective of this chapter is first we discuss the functions of the IP protocol. Okay, and then we discuss the IP address. Okay, the IP address, the types. There's different types: the public, the private, and some special IP address. And then we discuss the VLSM. Okay, the variable length subnet mask. And then the function of IP gateway. And first, this is the Ethernet frame, the format of Ethernet frame that we have discussed in the previous chapter. Okay, in this Ethernet frame, we can see this format is Ether2. Okay, the first two fields is the destination MAC address and the source MAC address. Okay, the MAC address is a layer 2 address. It is used for the destination search, okay, to identify the source and destination in the local network, local area network, LAN, in the LAN. Okay, and then the end field is the FCS, the frame checksum, to check if the frame is not destroyed during the sending from the source to the destination. Okay, and then, as we know, this is the layer 3 protocol. The data presents the layer 3 protocol. And as we know, in the layer 3 protocol, there are many different types, such as the IP, IPX, and others such as ARP, and so on. Okay, then how to identify what is the protocol contained in the layer 3? Okay, we use the type. This type field is the Ether2's third field. Okay, this field, if the value is 0800, just point out this is an IP packet. Okay, then what is contained in the IP packet? You can see. Yeah, this is the IP packet. Of course, this is contained in the layer 2 frame. Okay, the frame. Okay, this is the FCS, and this is the type. Of course, before the type, there is the destination MAC address and the source MAC address. Okay, then this is the layer 3 packet, and in the layer 3 packet, there's first is the IP header. Okay, and then the data. Of course, this data is the layer 4. That's the layer 4 segment. Okay, layer 4 segment. And then what is contained in the IP header? Of course, there are many fields. And we can see the field of the IP header is divided into two parts. First is the fixed header, and then another is a variable. This is IP options not exist in each IP packet, but the fixed header exists in each IP packet. Okay, the fixed header is 20 bytes long, and the IP options may be variable. That's from 0 to 40, and at the total, the whole is 20 to 60 bytes long, the IP header. Okay, but usually what we see in the IP header is a fixed IP header. Okay, then there's many fields exist in the IP header, and then most important is the IP address. This IP address just to identify who is the source of this packet and who is the destination of this packet. Of course, there are many other fields we will discuss later. Okay. And then the IP addressing. And the IP addressing is a 32-bit long value, 32-bit. Okay, this is a binary. Okay, 32-bit. And this IP address is divided into two parts. Okay, the one part is the network part, and another part is the host part. The network part just to identify what network is this IP address, is this host exist. Okay, then the host means in this network the host number. Okay, as we know, the network is organized as this. There's a one network and there's another network. Okay, each network must have a network number. Okay, maybe this is 192.168.1. Okay, and then this may be 192.168.2. Okay, these are different network. Okay, they must use different network numbers, and then for each host in this network must have different host numbers. Maybe this is .1 and maybe this is .2, and then that's .1 and .2, and then here also .1 and .2, and then these two parts combined together then form the IP address of one device, one host. Okay, and yeah, the IP address identifies networks. This is a network part, and the network host. This is a host part. Okay, and then in the computer we use a binary. And then in this number, this is the IP address we usually write in the for our human beings to see. This is the decimal format. Yeah, this is a decimal format. And then in the IP address, there's some special values. Yeah. Now this network, this is a network number. Okay, and the host number we can see there's different values, but two special values we cannot use to assign to host. Okay, one is 0. Okay, when the host part is 0 means this is a network number, network address. Okay, this IP address is used to identify the network, not used to identify the host. Okay, this represents the whole network. Okay, include all the hosts contained in this network. Okay, and then another address is a broadcast address. The broadcast address, the special value is the host value. It's all ones. All ones this value also cannot assign to a host. Okay, this is represented by all the hosts in this network. Of course, this network cannot assign to host, but this address can only exist in the destination IP address in the IP packet. In the IP header, there is source IP address, destination IP address. Then this address can only exist in the destination IP address. When the packet using this address as a destination IP address, then this packet should be received by all the hosts in this network. Okay, this is the broadcast address. Okay, and then we discuss some background knowledge of the decimal, binary, and hexadecimal. Okay, in the computer, we use the binary. The binary means there are only two values, 0 and 1. If you want to represent 2, then how to express this? That's 1 0. Okay, 1 0 represent 2. If you want to represent 3, then 1 1. Okay, this 1 means 2. Okay, and then the decimal. Okay, the decimal is we daily used. Okay, that's the value is from 0 to 9, and then if it's 10, then you write as a 1 0. Okay, this is a 10, and 11. Okay, that's 12. Okay, that's the 13. Okay, and the hexadecimal. The hexadecimal is another form of the binary. Okay, one character in the hexadecimal represented 4 characters in the binary. For example, this is the 0 and then to 9, and then 10 represented by A, 11 B, C, D, E, F. F means 15. Okay, means 15. And then the 15 in the binary just the 1 1 1 1. Okay, that's the 4 characters. E means 1 1 1 0. Okay, this is in binary. Okay, in binary. That's the 4 characters just represented 1 character in 4 characters in binary just represents the 1 character in hexadecimal. Okay, that's the 16. The base value is 16. The 1 0 in the hexadecimal means 16 in the decimal. Okay, this is the hexadecimal. Okay, in the computer, truly it's used binary, but for our writing, we use the hexadecimal to abbreviate the expression. Okay, and then in the IP address, we use 32-bit. Okay, 32-bit to binary bit. Okay, and then we can divide this 32 into 4 parts. Each part is 8-bit. This is just 1 byte. 1 byte. Okay, and the 1 byte have 8 bits. This is the 1 byte. And in this 1 byte, each bit represents different values. Okay, what is the value? This one, the last one, is 2 powers 0, and the second is 2 powers 1. Then the third 2 powers 2, and then so on. That's the 2 powers 7. Okay, in the decimal value, 2 powers 7 means 128, and then this 2 powers 6 means 64. Okay, we can calculate this, each bit value. Okay, and then we can count. For example, we have a value such as this value. We can see that's the 1, 1 means this is a 1, this is a 1, and then all the others is 0, and then this is a 1 and this is a 1, that means 2 plus 1. Okay, that's the 3. Okay, that's the 3. And of course, in decimal it's 3, but in hexadecimal it's also the 3. Okay, and the hexadecimal, that's the one character in hexadecimal represents the 4. Okay, represents the 4, and then we can see, yeah, from 1 to 8, that's the 1 0 0 0, that means 8. Okay, means 8, 1 0 0 0. Okay, and all the others are 0, and then just 8, and then 1 0 0 1, that means 8 plus this value, and the 1, that's the 9. Okay, and then this is a 10 decimal. In this decimal it's a 10, but in hexadecimal we can see this is the A, and then 11 means B. Okay, and then so on. Okay, this is the conversion. Okay, from the decimal, binary, and hexadecimal. Okay, the value that's equal. Okay, in one row that's equal, but in different expression. Okay, and then in the IP address, for example, this is the IP address. The IP address have 4 bytes, and then in here, the 3 bytes are network part, and 1 byte are host part. And then, how to calculate this? We can see this is 2 power 7, and then plus 2 power 6. And then we can calculate this is 192. Okay, 192. And then this is 7 and 2 powers 5, and then 2 powers 3. And then the result is 168. Okay, this is a 1, 1. Okay, so the binary IP is as this, and then the calculated decimal IP address is as this. Okay, you're better to practice and then know how to count between the binary and the decimal. Okay.